Pre-calculus, we're in notes 8.1, and this is the fourth video. Based upon your understanding of the value of a logarithm, what conclusions can you make about the values of the following logarithms? So for this one here, this first one, in this first column, we're going to try to figure out what we think the answer to this is, if we can find it directly. If we can't, between what two integers do we think the answer is? Keep in mind that this question, log base 3 of 81 equals 81, is equivalent to saying 3 to the exponent equals the argument. Now 3 to the first is 3. 3 to the second is 9. 3 to the third is 27. 3 to the fourth is 81. So we can confidently say we believe x is 4. This next one is saying 2 to what exponent equals 1/8. Now that might seem tough at first because we can see here that this is a fraction. But one of the methods that we learned when we were talking about exponential equations, which this now is, if we change the 1/8 to have a base of 2, this would be 2 to the x equals 2 to the negative 3. 2 to the third is 8. This is a negative exponent, so if we reciprocate the base, it would be 1/2 to the third. 1/2 times 1/2 times 1/2 is 1/8. That tells us that this answer is negative 3. 2 to the negative 1/3, 2 to the negative third would give us 1/8. Now this next one's a little more difficult. This is saying 2 to what exponent equals 9. Well, here's what we know. We know that 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, and 2 to the fourth is 16. So it's not an integer, because 2 to the third gets us below 9, 2 to the fourth gets us above 9. So our conclusion, here's the work that we would show for this. We would say 2 to the third is equal to 8, and 2 to the fourth is equal to 16. So our conclusion is that x has to be between 3 and 4. It's 3 point something. We just don't know what that something is. Next one, log base 3 of 36 equals x is equivalent to saying 3 to the x is 36. 3 to the third is 27, and 3 to the fourth is 81. 36 is between 27 and 81, so therefore the exponent of 3 and 4, we have an answer that's between those. So that means this is also going to be 3 point something, since x is between 3 and 4. Next one, log base 4 of 21. It's saying 4 to what exponent is 21? 4 to the second is 16, and 4 to the third is 64. 21 falls between 16 and 24. Therefore, the value of this logarithm is going to be between the values of 2 and 3. Log base 3 of 105. 3 to the fourth we've established is 81. And 3 to the fifth would be 81 times 3, which is 243. Since 105 falls between 81 and 243, that tells us that the value of the logarithm is going to be between 4 and 5. Now this right column says, given the expression log base b of a, so in this first one, log base 3 of 81, use your calculator to find the value of common log of a over common log of b. So let's do that. So here's what this is suggesting. It's suggesting that log base 3 of 81 is equivalent to common log of 81 over common log of 3. Notice how the original argument is on the top, and the original base becomes the new argument in the denominator. And we change the base to tens, to common logs. If you put this in your calculator and make sure that you have parentheses that open and close around your arguments, you should find that this is 4, suggesting that our theory at the beginning actually worked. Do the same thing for this next one. Log base 2 of 1/8. According to these directions, we should rewrite it as common log of the original argument over common log of the original base. Put that into your calculator. I think that you will find that it's going to give you -3, which supports what we thought the answer was originally. Now this next one's more interesting. We think the answer is between 3 and 4. And if you look, 9 is much closer to 8 than it is 16. So I'd venture to say that this 3 point something is much closer to 3 than it is going to be to 4. So the directions here are insinuating that log base 2 of 9, perhaps that's equal to common log of 9 over common log of 2. If you put that in your calculator, I believe you're going to get 3 and 170 thousandths, which supports our previous answer. The next one, log base 3 of 36 should be equal to, according to the directions, common log of 36 over common log of 3. In our calculator, this is 3.262, which is certainly between 3 and 4 like we thought it would be. The next one, this is going to be common log of 21 over common log of 4. And with the calculator magic, we get 2.196, which is between 2 and 3. And this final one, common log of 105 over common log of 3, that gives us 4.236. We are trying to build this story here for logarithms. With every piece of information that I give you adds to the story, and you can't understand the entire story here at the beginning. We're just trying to take baby steps, and hopefully we understand each step along the way. This leads us to the change of base formula. That's what this right column was leading us to. Here's what you're allowed to do. You're allowed to take the original base in the original argument and rewrite it with any base that you want. In this case, we're saying we change the base to C. You take the original argument, and it's the argument in the numerator. You take the original base, and it's the argument in the denominator. Now you might be asking yourself, why would I ever want to change the base? The most two common bases that we use in mathematics are 10 and E. So typically we're going to change the base to a 10 or an E. As long as these bases are the same, you can use this formula anytime you want. It's called the change of base formula. That concludes this video. Still got more for this section.